Okay, guys, sorry for being late, so I'll try a few things. Yeah, it didn't work as I like it to be, so I like that we have screencast, a video and everything, and so we have a nice video for everyone, but it doesn't work. So it's quality. So how we measure this kind of quality thing, right? So with metrics, so this is something that we will learn today. So what are the metrics? So you had some class on metrics. How many? How many? All the semester? All semester on metrics. So you will teach me something today, yes? So that's good. That's good. So I assume there will be a lot of participation. So you'll gain all these participation marks for today. So it will be nice. Yeah, it's assumption. Yeah, it's assumption. Right. But actually, yeah. Any questions before we start? Yes. Cool. Yes. Did you ask Evgeny? No answer. He was super busy because I saw I was mentor, and there is Alexander also said Alexander Naumchev. He noticed that he is mentor for some of the group. He contacted them. So yes. So Nikita. So yeah. So some people contacted. Yeah. Yeah. Some of them yes. Yeah. So the technical depth. But anyways, you read it. You have to read anyways for the lecture. Yes. No. I mean, yeah. It's quite. You can ask few things, but not all things. I will not. I will not. So you see me on this one. So did you see me? Yeah. Okay. I don't know, because I'm broadcasting as well. So, but anyways, you normally should see me. Yeah, I see myself on the screen, so it's okay. It works at least in this way. Some technical question after the lecture. Okay, few things because I mean, if it's too technical, no way. So there is special project, or you can ask technical questions. So we'll figure out that. So yeah. Yes. Which one? Yeah, there was a few things you need to go. There is specific references for RUP and stuff, but which one? Ishikawa. There was actually something in Nike. Yeah, but you found them. It's one line per tool. Come on, guys, you can do that even with this reading. Okay, it's 4 pages. It's 4 pages. Yeah. Ishikawa. Yeah, it's nice guys. Yeah. Process guys. So with lots of tools. How many? Yeah, you know that. You know everything. So it's good for having reading. There was another question, Artyom. No, I mean, you can put some references, but if you use your own words, yeah, the reference is good because it's justification. But it's in your words, meaning that you need to paraphrase, not copy paste. In your words, meaning paraphrase. How it very much depends, but I mean, basically, it's better you put something, or at least book from which reading you pick that, because we know those books, we read them. Evgeny was yeah, you hedgeless. Okay, put some of that. Good enough. Yes. SAP. Yes. Mm. Yep. Yeah. So they tailored this process for their use. So I mean, so the difference. Yeah. Somebody wants to ask something. Maksud, you want to know? No, it's okay. So we can start. You guess so? Yeah, so we have assignment number 1. So we will upload the project number 1, which will be about technical depth. So your readings will be helpful because there will be a lot of small calculations to done for the project number 1, which will be presented at some point, right? So it's just a small reminder. Yes. Quality views, yes. I mean, there is obviously good matches and bad matches, or many bad matches. I mean, you might exclude for a few different things. Dominant means dominant, but I mean, it's 5 choices. You can discard the other, which is not good. So the other might be better than the, right? I mean, for the guys with PhDs, it's probably not enough space. It's a shoshu or kind of visual literature. So it's probably not enough space, but you need probably to digest it, to make concise things. I mean, it's difficult to write in a concise manner, obviously. Just get rid of those not important stuff. Okay, if I just find this one, the best. Okay, no, it's okay. Yeah, you may do that. You may do that as well. There may be different answer for the same question. Yes, justifying is good. So I mean, it's basically to test how do you understand the thing. And so if you can justify or argue about this or those within this kind of category, it means that you at least try to understand, or you can understand to a certain degree, this quality views, right? Good. Okay, functional requirements. Some kind of repetition. So what's our functional requirements? Any guesses? Yeah, I mean, it's just, okay, you have good idea. Okay, so it's better one. So this room is better, yeah? So the quality attributes, so quality questions, how fast, how much, how many, how well, yeah? And so, I mean, today we're gonna, I mean, speak about how we define those things, yeah? How much, how many, how well, right? Just a reminder on the quality models, okay? So you have a product quality, right? And so there is different categories in different attributes, right? How we define reliability, anybody knows? Yeah, you got it. You know, time is important. Time for time. Reliability. We want the system to work to particular moment. So it's reliable. So for the plane, if it's broken on the ground, it's okay. But if it's broken in the air, it's not okay. So it should at least work till we get to the point B, from point A to point B, right? So time is important. Time is important. Yeah. So and basically, I mean, the different to all this kind of attributes, we can assign different matrices to let's say to measure whether we satisfy those things or not. So right. So we have our maintainability right here, and we'll discuss something. So there is functional stability, functional completeness, portability, compatibility, usability. So we'll discuss how you may actually you will discuss so how you can measure those things. Right. So why do we care about metrics? Yeah. You can predict. Yeah, good. Predict. How? So Andre, so what do you want to predict? You will discuss how. Hmm? Compare. Okay. Compare. Sometimes compare. Yeah. For example, mm-hmm. Mm-hmm. Server will fail. Okay. So now, can you repeat, please? Mm-hmm. Okay, because we have a history, and we based on this history and based that metric, we can predict certain things. Okay, so please, Marat. Paying. Okay, so cost. We can measure cost, because I mean we can predict some cost. Okay, so Konstantin. Yeah, improvement. So just witness or kind of detect something, detect improvement. Yeah, detect improvement. So what else? Andrei, did you say something? No, you already said something. Yeah. Eliminate just by measuring, by analyzing. Okay, eliminate risk. Okay, or kind of prevent, or like just the early signs of the risk. Eliminate risk. Yeah, risk. Good for risk. Nikita? Hmm? Any question? Okay, any question? Okay. You are good in readings, yeah? so okay, let me. Marketing. Okay. Marketing. Evgeny? Control. Okay. Control. Roman, will you try to ask us about control? You think you like, you just read your mind and you couple. Shahia. Trade. It's metrics? Okay. Trade. Okay, so anything measurable. Manuel. Yeah, so we see progress. See progress. See progress. Progress. This column, who wants to take? Nursultan first. Asset. Mm. Yeah, I mean, why not? Rustam? State. Progress state. Yep. Hey. Decision making. Yeah. So you detect risk, you make decision, and so on. So yeah, why not? Good overview. It's not readable, but anyways. And by the way, I think on the screen also it's not readable. Probably you need to screen it anyways. Anyway. Okay, so what for today? So what we are going to learn? What measurement, metrics, context in the context of software quality. Basically, this whole lecture is about what can go wrong with metrics. I don't know how much it was stressed during the other lectures, but we will discuss really thoroughly what can go wrong. Different fallacies. So then we define scales like precision, reliability of different kind of measures, right? Just some hints on statistics. You will tell me what you learned in last classes. So we discuss a few things about how to develop valid metrics, evaluate metrics in a critical eye, And I mean, so some approaches to setting up successful metrics program. I'm not quite sure that we'll discuss that, but anyways, the rest is also quite important. Right. First of all, let's look at this one. This is something called metrics viewer in Visual Studio, and they have this kind of maintainability index. Are you familiar with that one? No? So we'll discuss how they calculate, and we discuss is it important or not. But basically, it gives you different color codes. And so in some sense, when it's green, it's okay. When it's yellow, it's not that okay. It's probably a risk, as Leah said. Or when it's red, you probably should take attention to that. I think it was one of the features of that, so it's not really a plugin. So what we can tell about that one? So there is form one, like program. There is cyclomatic complexity, class coupling, steps on inheritance, lines of code, and maintainability index. And all of those says it's okay. It's not okay. Why that? So yeah, why don't know? Why there is kind of why do not yeah. Yeah, it doesn't affect. So yeah, it seems that this red doesn't affect really the other one, right? Depth of inheritance. I think so. This I mean, it's probably yeah. I mean, we don't know. I mean, in this one it's okay. In this one it's 7. It's not okay. So why we don't know? Because I mean, we don't really know what does it really mean. Yeah, with these numbers. We know, you know. Yeah, you know that. Huh? Okay. All of them, yeah? Except maintainability index. Yeah, okay, because I mean, all of that, you know, I mean, basically they appear in different classes on matrices, but this one, it doesn't appear. And basically, so do you understand the scale? Or absent inheritance for maintainability index? White is green between 20 and 100. Do you understand that? Just because. Can we, huh? Yeah, I mean, the maintainability index is green when it's between 20 and 10. So, and standard. Is it valid all the time? Depends on customer, depends on language, depends on many different things. Yeah. So first of all, we need to understand the scale, so how it's measured. Then we need to understand the thresholds, what were set. Are they if they're relevant or not relevant? So, and then we can actually take decision, because I mean, we said we will take decision based on those red, yellow, green things, right? So when we said it's important. In studio, probably not. I mean, we'll discuss that. We'll discuss it later at the end of the lecture. So why they put this kind of thing. So whether you need to change it or not, right? Okay, but now we can actually understand when there is more kind of difficulties with matrices, because I mean scale. Okay, scale we don't know. Threshold we don't know exactly. So can we make a decision based on that? Right now, I would be a bit scared to make any decision based on that. So let's discuss. Probably they are right. So let's discuss that. Okay. So what Sonnet says, so software quality metric is the function whose inputs are software data, whose output is a single numeric value that can interpret to degree which software process are given attribute that affects the quality. Basically, there is another one. Yeah, we'll discuss that. So basically, what the definition says, if you remember this meta model from the last lecture, so we have a quality attribute, and quality is a quality model. The quality depends on this quality attribute. We can measure them, and if you see something, it may affect your quality or not, right? And we have this nice book which says you can measure anything, literally anything. And basically, probably better definition is that metrics or this measurement can help you to reduce some uncertainty. So the only meaning for that is just to reduce uncertainty. So uncertainty is so important in our lives, and we as engineers want to reduce that as much as possible to make decisions, have a happier life, right? And basically, this matrices and measurements will help us to do so. Okay, good. So about the measurement, so we need to know so what measurement represents, how accurate it is, right? So probably we don't know how those things were measured. Probably they are not so accurate. So, and basically we need to check that. How precise the measurement? What is the resolution of the measurement? Do we measure everything in millimeters or in meters, right? Or centimeters? Which scale? And in this particular context, does it matter if we use this scale or another scale, right? Okay, and now the core part of the course is about the danger of using matrices and different problems that aviation may have, and you will tell me if you know some of those, right? Okay, so about statistics, so one of the examples. So in 1991, there was actually some study in UK at medicine, and they said that third generation of some pills would increase the potential of life-threatening blood clots in lungs by 100%. So how would you actually interpret this one? So is it bad or good? As a general population, how you would do you see anything? How you interpret that one? So I don't buy this medicine. It's really alarm. So I don't buy this medicine. It's 100% worse. This one actually, this announcement actually affected the birth rate in UK this time. So they say, okay, pills are dangerous, don't take them. Okay, but actually, so in original one, there is kind of one every 7,000 patients that was affected, right? And I mean, in second generation, it was like 2 out of 7,000 people affected. So in relatively, I mean, it's a lot. 100% is a lot. So it's kind of something that you need to understand. So, but absolutely, actually, in numbers, the risk was not so high, anyways. So, yeah. So this is how you interpret that. Hmm? Yeah, it's not statistical. I mean, it's really it's 100%. So you cannot really argue. So they were actually right, but the way they actually presented the message. So I mean, you can interpret that in the way that is so dangerous you should not take. If somebody tells you today it's 100% dangerous to take a plane or to walk on the street because of whatever weather. Yeah. So and basically, how you interpret this statistics may actually affect quite a lot behavior of different people and your decision making, right? So you need to understand what's behind and actually how to rightly take decision about that. Right. So there is some explanation. You will read that. And basically it says it was not that dramatic as it looked like. You read that, and with different kind of explanation. So another danger. Do you know this man? No. This particular guy. Looks like dangerous, huh? No. It's the president McNamara, and there is specific statistical fallacy called after his name. He was the president during Vietnam War, and for this, he's actually famous for taking decisions based on numbers and exclusively on statistics that he can trust. If there is some significant difference or something that cannot be measured in numbers, like quality of life or something. So in terms of injuries, for example, Vietnam War was not that bad actually for US. Casualties, sorry, casualties, so people dead, soldiers dead. It was not so bad for them, but actually life quality, injuries, and so on was so bad. And actually, this guy, for this guy, it actually took too long actually to stop the war because of his decision making in this way. So and basically the fallacy here is that if you only take the data that you can actually be 100% sure that that's the right one, so we can take decision on that. So, but there are actually different other parameters that can be quite important. Right. Okay. So another fallacy. So we already saw that an MSD class, right? So, and what happens if somebody says, for every bug you find and fix, I give you $10? You will make bugs, you will solve them, so you will find a lot of them. So this is actually a fallacy when you try to use matrices to as incentive to motivate people, right? Okay, so right now we all find bugs, and when we found everything, we have a bonus or something. And so if you use strongly, like, okay, I will pay you for each function point you make, or like if you reduce the climatic complexity, or so this can be a different thing that doesn't make sense really in real life, but they actually can make people do, like, let's say, stupid decisions, stupid things to actually get some bonuses. So if you use this matrix for incentives, it might be actually quite dangerous. Have you had that on your? I mean, I think you will be the first to understand that one. I'm really surprised. I mean, yeah, but okay. So if I tell you, I give you $10 to find and fix a bug, so what will you be doing? Yeah, you'll spend all your time. You will create some bugs. So you will create some bugs to fix them. Yeah. So or you will talk to Ilnur. He creates bugs. You fix them and then share the $10. Yeah. Or you just pay some Chinese. They go in the. Or you just import the open source library which is not stable, and then you fix the bug. So because it's so important in your software that you can't really avoid using that one, and so forth. So I mean, if you use these matrices for incentives, it might be really bad. Just real example, like I mean, all faculty somehow we ranked by Hirsch number, which is kind of number of citations, right? And there is lots of very clever researchers that, okay, they have let's say mafias that actually cite everybody. So I cite you cite me. So they raise the level of citation. Or we have a paper with 20 people on the paper. So each time it's recited, so I have 20 citations. And so I can augment. There was also a study when kind of the highly cited guy like was making like paper each 5 days. It's not possible. Come on, you can't really make that. But I mean, with different kind of arrangements, you can actually make that. So I mean, and this is only because the incentive is wrong. So when the guys like made a Hirsch citation index paper on how to evaluate this research, they said, please don't use it for motivating people or incentives or putting that as KPI. That your payroll or your status would depend on that. And I mean, and we did everything wrong. And now, I mean, the whole industry is actually on citation based. So you are a good researcher if you are kind of cited very much. So yeah, so this is a real example. So we can cite different other KPIs or metrics examples with policies, different policies in economics or administration. So you can find many. Right. So incentives are not that bad, that good if you use them wrongly. So you may use that one, but you should be really careful about that. So I think there are good ones. Like if you would like to make very good product and you diminish variability of different parts, right? So you can measure this variability, you can diminish that, and this would be a very good because it brings the right incentives to improve the quality. That is like Japanese car makers became very good because they used the right incentives, they measured the right thing, improve the right process in the right way. But if you do it wrongly, you can get absolutely different results, right? Any other examples from your side? So grade, or kind of, if you, let's say, it's kind of, let's say, cheating within the rules. So I mean, in student's life, I think it might be actually possible. Yeah. Yeah, pay for lines of code, for example. So if I pay for lines of code, or how you kind of, you want to some program and you hire some outsourcer, and you don't know how to pay. Is it for results? Is it for lines of code, or for the time? If you pay for the time, he will spend as much time as he wants, or if feels reasonable. If you pay for lines of code, he'll make you a lot of time. It's like some novels were written like if you pay by page, and so we have books like this. Yeah. Mm. Yeah, for example. Yeah, so we'll discuss that as well. So yeah. Mm. Mm. Uh-huh. Mm. 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 Ah, okay, interesting. Yeah, there is actually on Hubbard there is long stories about KPIs for programmers. You should read that because they really see all the process, all the metrics, how they can use wrongly for evaluating the people. Yeah, another example, if you, for example, yeah, in maintenance and you pay people for fixing bugs. So, and I mean, if there is small things, there are lots of bugs. Okay, there's some of them less important, so they will keep like fixing the small bugs and then leaving the hard bugs for later for somebody else. And then that way they actually will get the bonuses and they get the metrics high. Or in a call center, if you paid for like each call you receive, you just speak for 5 seconds, you close, they call back. I mean, there is also a lot of things how you can actually, let's say, bypass the system and actually use this incentive in the wrong way. So you should be really, really careful about that. Good. Another example of the fallacy is called street light effect. Do you know about that one? You can't probably read it. You have a good eyes or bad eyes. So I mean, usually people avoid hard problems. For example, if there is street light, I mean, you are on the parking lot or kind of on the street at night around 4 p.m. here. 4 p.m. you go out, you just you have your card from a canteen or whatever, you just drop it, and I mean, usually your first instinct is to look in the spotlight of the street light. So and you look here when it's clear, so not there when probably lying, because I mean it's quite easy to look in this place. And so the idea is that as humans, we actually want a simplest solution, a simplest search. So when it's easy to do. So if it's hard to do, I mean, you usually struggle to use that. So it's called kind of observational bias, and so it can be applied in statistics as well. So okay, you see something like this happens a lot, so I will dedicate my attention to this particular part. But actually, there is different factors that actually can affect some performance, and so you would not naturally look at this factor. So you should be careful about that as well. Good. So we can categorize those things like bad statistics. So probably data is wrong, or you misunderstand how the measurement is done, or what is being measured exactly, and so you interpret that wrongly. Like we discussed with this medical study, right? So you may take incorrect decision, right? Like, okay, my decision is give $10 for each bag. So that actually could lead some unintended side effects, like this pointy-headed boss would probably regret his decision to pay for this $10 for each bag. And also like bad incentives. So because we often discard the human factor. And when you are going to be managers, how you can evaluate your teammates or in your company. So if you use your wrong measures, so that would be probably wrong, because you will just causation. We will talk about that. We will talk about that as well, about bad statistics. Right. Yeah. So let's discuss scale, precision, reliability, and validity. Right. Good. So what's a good scale? So the scale should represent somehow the reality, make a sense of reality. So we should really map the real world to something, yeah, to what we understand. So if it's kind of weight, it should be weighting something. You should understand, like uniquely, let's say, and everybody should understand how much it is. So if I say 1 kilo, so 1 kilo of apples, 1 kilo of whatever. So it should be almost the same, right? So if I say color, most of us should say that yes, this is the color that you indicate, right? So and this is actually something that we need to discuss, right? Because there is different ideas, like how we measure things, and different difficulties when we measure things. So look at this example. So how many of you will be using Scrum at your project? 1, 2, many, whatever number. Oh, somebody will use Scrum. Okay, and consider this one. This is a real project that was actually in SteamU, and so They did some statistics with median number of hours to complete a story. So, and if it's 1 point story, like it was at 21, and the range was between 60 and 26. And for 2 point stories, it was about 31 to 73 with a median of 52. So I mean, basically, 21 multiplied 2 not equal 52, right? So I mean, how you can compare that? How you can say, okay, I have a 3 point story or two point story. How I can predict what number of time I would need to complete that one? Because I can't just really multiply by 2 and saying that would be my number. Because statistics is what they have. So they had 2 point stories, multiple of them. Some of them were like 31, and some took them 73. And basically, what we care. Range. It's statistics. It may be that one or that one. You measure that, and this is what they measured. So, and 52 is a median. Do you remember median? About median? So we'll discuss that. So we'll ask Maksut to remind us what the median is, or mean. Basically, so in the first case, median was 21, and the second case, median is 52. And basically, there is some misunderstanding, and like there is no perfect estimation for those things. So it's much difficult to estimate 2 point stories than 1 point stories. And they could be actually correct it with specific techniques like regression analysis to find out the true value of different stories. So actually to help the team to estimate. But this is to show you that, I mean, this estimate may be actually quite wrong, even with this technique. Right. So let's do other definition. So this about low accuracy, low precision, right? So we have we're shooting a target, and we are targeting the center, and we have some kind of all wrong. So low accuracy, low precision, and the distance between those things are different. Yeah. Yes. You can see on the slide. Let's discuss that. So how I understand? So this is low accuracy and high precision. So what's different between two of those? Precision, yes. The precision is how close they are around some point, right? Between them actually, between them. So precision and resolution might be actually somehow connected, and low accuracy, and I mean they are quite close, but all wrong. So they're not targeting this one. So I mean this one, for example, comparing to two of those, there is high accuracy. They are all almost there, almost targeting the center, but still they're not so close to each other. So the precision is not that good. And this one is perfect. Okay, so there is high accuracy, high precision, and so they also are targeting the center. Okay, is everyone? Good. So scale. So we'll discuss all scales, right? So we have several scales and discuss them thoroughly. Nominal, it's kind of categories, right? You know that? All of them. Okay, so then you tell me, what's nominal? Can you give me an example of nominal? Apples, oranges, yeah. So how many apples, how many oranges? Yeah. True, false, yeah. So ordinal, high, low, and how and like how much of low would make you a high? No, that's what. So I mean, like you have a let's say critical bugs, non-critical bugs. How many non-critical bugs will make you critical bug? Yeah, Nikita says. Yeah. So yeah. Okay. So okay. Okay. So like 3 is a many. Yes. From 3 it starts many. How many? Yeah. Hmm. Yeah. Why that? And so that doesn't really compare. You can't really compare them. I don't understand this example. Yes, Nikita. Yeah. Yeah. Hmm. Yeah. 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 And yeah, the good also is a student's mark. So we don't know how much B's, how many B's will make A, or, or C's will make B. Yeah. So interval. So everything matters except 0 because we don't know where the 0 is. So good example is Fahrenheit temperature, right? Um, so otherwise, ratio. Yeah. So what ratio? Everything matter. Yes. Order, magnitude, 0. So Celsius degrees. So matter. So why that? Why Celsius degree would be okay? So let's compare temperature. So is 5 degree is comparing to 10 degree is twice as cold. Okay, okay, it's personal. Okay, it's a good bad example. Bad example. For me it's okay, but for you not. Yeah, ratio would be ratio. Yeah, twice faster. Yeah. Okay, there is actually something. So I mean, there's categorical scale, and they say basically what we discussed. So like you have attributes like categories like e-commerce, and finance, or languages, Java, Python, C Sharp. Sometimes we can say there is more programs in C than in Java or whatever, but you cannot really argue about different other things. So how many C programs make a Java program and so on. They're not really comparable in this sense. So yeah, then you have ordinal scale. I like very much this bugs of fault severity because it's a really good example. Like you have cosmetics, moderate, major, critical fault, right? And as we discussed, like in incentives, I mean, I pay you for any fault, like telling you 10 euros. So then your incentive would be to solve many small things like cosmetic, but it doesn't help you to really improve your system because there is probably nasty, very critical bugs that actually make things much worse, right? And because I mean, 5 cosmetic bugs doesn't make any critical bugs, whatever. But sometimes actually we assign some numbers to those things to compare, and it may be rational or not. Like okay, we say critical is 100 and cosmetic is 1. So we measure like we can actually assign some hours, for example, for critical. Yeah. So and sometimes actually it's reasonable to estimate that in that way. Interval. Okay, we said okay temperature, for example, is a good example for that one. Right. Then the ratio scale, so effort like in hours and so on. Complexity, like economic complexity, we can actually, let's say, calculate it quite easily and can compare this number. And twice much more complexity, trigonometric complexity would be twice complex, right? And so on. So, and there is a summary. You will read it. So if you don't know it, But I think you already had your classes, your exams, and everything about that. Good. So now we'll discuss how you would understand your data, and you will teach me a few things because we have statistic classes, no? Yeah, me too. But I was told so long ago, so it was last semester for you, so you'll probably teach me something. Right. Okay. Distribution. So what? Okay. Let's look at this one. Sorry. Let's look at this one. Where is mode? Which one? So this 1, 2, 3, 4, 5. So 2 is a mode. Yeah. Everybody agree? Disagree? Maksud? You do agree? You agree? Okay. Because those questions for Maksud. Okay. So, and who can explain, Maksud, what is the mode? No, it's not the highest. It's most probable. It's actually, so okay. You have 1, 5, 5, 5, 5, 5, 100. So 5 is most probable because there's lots of 5s in this kind of set, and so 5 would be the most. Because I mean, when we decide, okay, we'll discard some outliers, or we'll take the core, and so the mode would represent you something that's really probable that you'll have. Right? Okay, where is mean? 4? Mm. Okay, so what do you think? 3 is what? Is average. Mean. Mm, mm, maybe. Let's look at this one. No, no, no. This is a mean, and this is exactly. You can understand that. I mean, it's actually skewed on this side, and so I mean, what is median? What is median? It's not a center. You have half things left, half things right. So if you have more things that way, so the mean should be also kind of closer that way than the other way, right? So I mean, it's logical, yeah. So who can give me a good example of median? Yeah. So I mean, a good example would be average salary in particular region or average salary in the industry. So what is the average salary like for IT specialists in Kazan? Yes, average by Kazan or the region. Because they tell you sometimes, okay, our scholarship is like as good as the average salary. Yeah. Average. But I mean, to understand that, so how to can interpret that? So average salary would be actually the right example. So what is medium, mean, and medium? So yeah, I mean, yeah. Imagine there is very paid or very low paid people. So they will actually influence the average. So I mean, if you have very rich people, right? So the average will be much higher than the real, and so you can't really, let's say, make a decision based on this particular average thing. So let's say in Russia, like let's say in Moscow, like let's say the average would be salary would be 100,000 rubles. But actually, if there is so many rich people, so and they overweight the other. So, or kind of, they're so rich that few of them would overweight all the others. That's it. So, in this sense, actually, median would be much better because you already know that half of the people in this particular region would gain this particular salary and half the other one. So then you'd probably be much better if you argue or decide on this kind of median side, right? Any other example for median average? Yes, yeah, temperature in the hospital. So it doesn't make any sense, yeah, because we can't really compare because of scale, right? Because not because of mean or average. Precise, which one? This one? Yes. This one? Ah, legend. So this is mean, this is median, this is mode. Mode is simple. Mode is simple. The highest point would be definitely in distribution in the histogram. The highest point would be the mode, right? Not equal parts. So we have more here and less here. This is median. Yeah. Because this is kind of occurrences. So you have as much as occurrences. Yeah, the surface would be the same on the both sides. Yeah. For median, not for mean. For mean, no. For median, yeah, they should be equal number of occurrences here and here. So definitely this. So then we have standard deviations. Yay! So let's test who we understand any standard deviation. Yeah. Okay. So we have this one, some mode or mean or whatever. So the good thing to understand is standard deviation, right? So it's how variable your set. So how data is probably something that let's say related to precision, what you meant. And so there is like 2 sigma, 3 sigma. Okay. So do you remember what this? So where is your sigma? Sigma? -1 or -2? So this is the sigma standard deviation, and so most of the values would be in this particular area. Have you had your readings on how to measure everything or anything? How you like it? So what he said about 5 samples rule? Yeah. Usually the same. Yeah. So I mean, in this book, just try this reading. It's very good. It's actually very helpful advice. So he says actually, so you need less data to measure anything that you imagine. So imagine you need to let's say to try like to see average age, what kind of age group you have among students and MSIT. You pick 5. There is a good chance that the 90% will be 95 something percent will be between. Yes. Okay. Yeah. So we'll be between the minimum and the maximum. So that you're gonna actually really evaluate some range that can be valuable for you, right? Good. Okay, we saw that, and okay, correlation. You like it, I know. So what's correlation? Correlation. What is correlation? So can anybody, Maksud, can you explain us correlation? relate. Yes, relate, correlate, or correlate. So it correlation means there is a relation, right? So there is a relation. It's relation. So how we can explain it in your words, let's say, or anybody can help? Huh? Ah, you said that. You you heard them. You heard them. He said dependable. No, you can't use dependable word when you talk about correlation. You should learn that last semester. It means relation. It's a visible, so observable relation between variables. Behavior. They move together. They seem to move together, right? They seem to move together. Yeah. Yeah. The one increases, the other probably kind of increases or decreases between if it's positive or negative. Yeah. Yeah. They move together or move alone, but they probably not dependent. So like everyone goes to cantina, but probably at some particular moment, but it's probably not that correlated. I don't know. Yeah. Hmm. Yeah, they might be negative. So to give you some correlation, so this is like a few examples. There is a ton of examples of wrong, like dependability. When people say it's dependable, like Andre said. So so correlation is not causation, not really dependency. Like do you really like uh, do you really believe that divorce rate in main state in US and per capita consumption of margarine is dependent? Look! It's so close. It's so close. How how margarine fertility? So you think you should dig down because I mean it can't be that kind of thing. You divorce. It's very far stretched. And what about people who doesn't eat margarine at all? I mean, it all. So I mean, so if you start to consume margarine, it's highly probable that you divorce. Yeah. Well, probably so. I mean, you consume margarine, you won't be much more healthy, right? And this is because you are looking for another partner, yeah. Or it's late. Nonsense. You think so? Okay. Might be. Who knows? It's like a number of films with Nicolas Cage and like people who drown by falling into swimming pool. How Nicolas Cage can be related to this guy? It's highly related. Highly related. Okay, so all the time. Oh, hmm? Oh yeah, the film so bad. So yeah, man. I don't think it's all of those things was suicide. So I don't think so. So right. So I mean, you understand from your course, relation, not causation. Good. Okay. And yeah, another thing, bias dangerous because you may say that some variables are co-founding. So who can explain that? This kind of fallacy. So yeah, if you don't account for coffees, you may conclude although coffee brings you cancer. And this, I mean, we're pretty much sure that the smoking is high. I mean, may cause cancer, but coffee we're not sure because I mean, if you just accounted for the coffee, I mean, because people that smoke that consume coffee as well, and I mean, if you do not account really, if I really on coffee, I mean, there will be high correlation between like coffee consumption and cancer. You think so? I mean, they actually made quite good. I think those who said that one coded the other one, they were pretty much sure about the data. So, and they counted for many different factors. Yeah, Evgeny? Ah. Hmm. Yeah. I'm for vaccination, but there is also some things that some agents that they put there that might be not that healthy at all. So you need to choose the right vaccine, even if you kind of, yeah, difficult questions. Let's not bring that one. Good. So yeah, I mean, in object-oriented, there's different. This confounding happens all the time. So some variables depend on others for wrong reasons, and so that might be not that good for your decision making. Yeah, in other comics, it's like Andre say, or kind of Maksud said. Who said that? You said that. So you, yeah. So you sort of. Mm. Ah, okay. Okay, good. Yes. So basically, we say okay, but sometimes actually correlation matter really, and so I mean you to let's say to prove this causation, you need to prove theory. So we already started to develop a theory about margarine and divorce rate, but it was not so sustainable, I would say. So then you show correlation and then demonstrate the ability to predict new cases. Because I mean, if it doesn't hold in the future, and this correlation doesn't really mean anything. Because when we use a measure, we want that this predicts something, right? And so in the future, it would be almost the same, right? Okay, significance. Who can explain significance? Yes, good. Yes, can you count on the result? Yeah, what's the error? What's the significance of the result? Can you count on the data or not, right? How much error you have in a calculation. Usually statistician doesn't say it's right, they say which error they have. So that's what they say. Yeah, I mean, if you just blindly compute your statistics, it might be completely wrong because your significance is not that good. Good. Yeah, varied metrics. So again, famous book. You missed it from your reading. Some of you, Nikita did it. How to measure anything, right? So this guy saying, okay, if it's something you care about, yeah, he's starting with a real high goal. You really care about something. You care about quality, or you care about security. Yeah, it's difficult to explain what it is. Yeah, it's difficult, but you care about that. So by his definition and his experience, it's something that you might be detectable, right? So you care that then you might somehow observe and detect this kind of thing, right? So like quality, risk, security, public image or something, you can then explain that with some kind of measured mean, right? And so, I mean, if it's detectable, then it's detectable in some amount. Yeah, more risk, less risk. So you can detect it in some amounts, right? You can argue about that. And if you can observe that in some amount, it can be measurable, right? So we have a class exercise now. What do we? So you did your exercise on 5 views. Which particular view is affected by this definition? Hmm? Not really. There is transcendent view. Yeah, very good, Arthur. Transcendent view. What transcendent view says? So we cannot really explain quality at all. So I see it, I feel it, and then I know it. So, but the other guy say basically we can say something about those things anyway, if we care about them. Who cares about these pictures? Any art lovers here? Nobody. Shocking. Which one is beautiful? Why? So you care. So okay, let's try this one. Okay. So we care about something. Yeah, we care about something, and so then it's detectable. So what we can detect here? What we care about? Nature. Okay, nature. It's natural colors. There is kind of different style of putting things together, so it's very kind of expressive. Yeah. It's I mean we can say also the quality equals beauty somehow relates to quality. Yeah. I mean if so you detect the quality thing also by if it's beauty or not. Yeah. So why you use iPhone? It's beauty. Yeah. Fine. I mean, but the other guy say okay, if it's something you care about, it should be detectable. Somehow you should understand that this thing is beauty. You decide for yourself. It might be subjective. It might be not good for everyone. Huh? Yeah. So you decide what attributes you would like to measure, and yes, and then you can compare. So that's what he says. And I mean, some of us more philosophical than the other ones. So and some are more kind of practitioners, let's say, or kind of down to the earth. And so for them, actually, we can dig down what the beauty is. But the idea is the guy saying that in his experience, he could actually explain, or with the audience, he actually could find why this is more or less of those things. We collectively can select the objective scale, colors, style, kind of dimensions, is it 3D, 2D, or whatever. Or we can use combination of those for this one. So it may be price. So why do you care? Because it's so important. I want it on my wall. So we just, I mean, the scale may be that way. So we ask like let's say 1,000 people which one is beautiful. If they select 1,000 of them select that this is beautiful, we consider this beautiful. Yeah. Yeah. Sharpness, yes. Technique. I think the earlier masters, they were kind of techniques, sharpness, how many different objects they had. I think with the Holland pictures, small pictures, it definitely they know what they were selling because they were, in this era they had food on the picture, different colors and different light, and so I think what they were selling because they were selling something tangible because the people that bought it was very pragmatic in a sense. Right. Anyway, a difficult question, but still we can try, and we will try as like maintainability index, right? So how can you explain that? So difficult, but we will try anyway. Because if we can measure something, we might actually, if we can measure something, we can reason about that. And even if we have some indication and may low uncertainty about the work, we can say, okay, we need to pay attention to this particular module in the program because we need to maintain that at some point, right? Okay. And it's actually, we are starting to get too close to the end of the session. So basically, measurement validity. So it should be like valid by construction. So you need to construct. So what we intend to measure. So it should be predictive. So so you may use this kind of measure to predict something in the future. Will this module be more maintainable if you change something? And this measure would help, or will it be more beautiful if I add more objects on the picture? There might be some external validity. So a generalization of these findings to context environments and other studies, right? So so the measurement can be valid in different contexts by different people, and so it can be repeatable, something repeatable, right? There is kind of operational definition for this measurement. You can read that one. I don't think we will go to work on that one. So there is important books about this measurement. So, but basically two things: communication. If I tell you about kilograms, you understand what it is. So basically, it works well, so we can communicate. It's repeatable. So if I have 1 kilo of apples, if I measure with this scale or another scale, it will do the same, right? Repeatable. Good. But actually, there might be actually some kind of problem, depending on the context, especially in this kind of software metric. Imagine you need to measure number of hours worked. What do you count for? Do you count for breaks? Do you count for vacation? You pay vacation, so which you should get money from somewhere. But do you count for vacation or for break? Do you account for extra time you need to spend or not? So this might be difficult. So imagine you counting lines of code, right? Do you count all comments? Do you count headers? Do you count empty spaces? Do you count breaks, semicolons? So how do you count that? So I mean, if you should be actually comparing the comparable things. So and depending on the tools, it might be not the same. So different tools can, for this particular measure, they can give actually different numbers. So it depends how they count that. Good. GKM. Yeah. No GKM anymore. No. Okay, so we will not spend time on GKM. But basically, you will use GKM to subdivide as a quality model. So it's actually going actually pretty much the same. You have use, factor, criteria, and the metric, and you define a couple of metrics to describe particular things. And so if you go back to, okay, there was actually quite interesting discussion about maintainability index. Basically, this is the right formula for this one. This is the right one, but this is how they actually, Microsoft decided it will be. And the reason for that is actually quite interesting. So it all started in 1992 with this paper, and this was designed for C and Pascal at the beginning. And so when you have these numbers, that might be actually quite wrong if you compare that with the Java. So, and basically, Microsoft doesn't use this kind of logarithm scale or sinus something. So they actually use quite different one, because they have on the blog, they said, so their scale was good for C#, for example. So it might be different actually for Java, different other things. So should be careful. So this is my last word for the lecture. I think we should end because we have plenty other things. Any questions before you go home? Not at all. Technical debt. That's the important one. So you have to learn about. There is some instability, some testability inside. So you might struggle. You might use Stunner. Okay.